Hey guys, this video is going to go into more detail on how to find the area of a regular polygon. So pretend that I drew these so that it looks like all of the sides are equal, because that's what a regular polygon is. So the formula for all regular polygons is 1/2 times the apothem of the shape times the perimeter of the shape. So the apothem comes from this little right triangle that is from the center to one of the sides perpendicular. And so what that does is it essentially cuts the side in half. If I were to draw this other side of the triangle, this triangle would be isosceles. So those two sides are equal, which means the two pieces at the bottom are equal. So the apothem is this part right here. Basically like the height of that little right triangle that's created. The other side of the little right triangle, that like the hypotenuse looking side of the right triangle, is the radius of the shape. So you might have to use the Pythagorean theorem at some points to find what the apothem is, so just be ready for that. And you might also have to use Pythagorean theorem if you're missing what the side of the shape is. So just keep in mind you're working with a little right triangle that is half of one of the sides. And so perimeter means you have to add up all the sides. And if it's a regular polygon, all of the sides are the same. All right, so we are going to talk specifically about hexagons. Hexagons have a very special type of a triangle that you were supposed to have covered in Math 2, but because of the COVID situation, you may not have gotten there. So in a regular hexagon, I am going to draw 6 equilateral triangles in this regular hexagon. So hopefully you can see that there are 6 equilateral triangles. If I measure the angles of the tops of all of these triangles, it's going to create a circle. A circle is 360 degrees. So that means each of these angles at the top of all of those equilateral triangles is 60 degrees. The right triangle is going to split that in half, which would make this 30 degrees now, right? Because the whole angle would be 60 degrees, and I just cut that in half. So because a triangle adds up to 180 degrees, if that's 30, that's 90, then this is 60 degrees as well. And so that is also 60 degrees because these were equilateral triangles. So that's going to make all of the angles 60. So I just drew it the other way around. But basically, you have a 30, 60, 90 triangle whenever you're dealing with a regular hexagon. So there are certain ratios that are for all 30, 60, 90 triangles. So first of all, this is the hypotenuse of the triangle, which would also be the radius of the whole entire shape of the hexagon. The part that is your apothem, this side is going to be your A, and this is also going to be the long side. The apothem is going to be the longer of the two sides. Because it is across from the 60 degree angle, it will make that side bigger than the side across from the 30 degree angle. The 30 degree angle is across from, this is basically going to be like the side of the shape, but this is the short side. But that 30 degrees here, I'm just going to put a little tick mark on it. That would be coming from there. And this is your apothem. All right, so in a 30, 60, 90 triangle, The 30-degree side, the opposite side, this is the shortest. So I'm just going to label that X for now because we're obviously going to have different answers for what that side is. The hypotenuse is always double the short side. And honestly, from there, you could just do Pythagorean theorem to find the apothem. But you do have to remember that in a 30, 60, 90 triangle, the short side, multiply the short side by 2, and that always equals the hypotenuse. But no matter which way you do Pythagorean theorem, the long side is going to end up being your short side times the square root of 3. So those ratios exist for every single 30, 60, 90 triangle. So you should write that down. If you have a hexagon, you're going to need that. All right, so in this example, a regular hexagon has a perimeter of 96, and our goal is to find the area. So I'm just going to sketch out, like I said, pretend I know how to draw a shape where all the sides are the same. So my formula is 1/2 A times P. They already gave me the perimeter, but I am going to need to split that up so that I can figure out what the apothem is. So 6 sides, so 96 divided by 6 is 16. So all of my sides are 16. All right, so I'm going to sketch my little right triangle. So I know if this whole entire side was 16, then this short side is 8. If that's my short side, then my hypotenuse is 12, or sorry, my hypotenuse is 16, because your hypotenuse is always double your short side. So if my short side is 8, my hypotenuse is 16, and then I know that my apothem is going to be 8 square root of 3. And you could do Pythagorean theorem, you could do 16 squared minus 8 squared, but it would simplify to 8 square root of 3. And so what we do a lot of times when we have square roots is we do the multiplication that we can without the square root. So I'm going to multiply the 1/2 and the 8 and the 96. The 1/2 times 8 times 96, and that's going to give me 384. And I'm just going to write my answer as 384 square root of 3. You can obviously multiply and it will give you a decimal, but 3 is not a perfect square, so that's going to be an irrational answer. And so a lot of times, instead of rounding it, we just leave the square root part alone. So it almost looks like you have a coefficient. All right, but again, this rule is for regular hexagons only.